You ever really stop to think about what makes things, well, move in our world? I'm not just talking about big things like cars, but all the little whirs and spins that happen around us all day, every day. Well, it turns out the answer is often a single amazing invention. Today, we are diving into the machine that literally spins our world, the electric motor.
That's right. These things are absolutely everywhere, just humming away behind the scenes. They're like these invisible engines that power our entire civilization, quietly turning electricity into the physical force that shapes our lives. And the wildest part? We barely even notice they're there.
Just think about it for a second. That fan cooling you down, the blender making your smoothie, that incredible silent kick when you step on the accelerator in an EV? Yep, it's all powered by the exact same basic idea. It's a technology that has totally changed the game.
And that really is the million-dollar question, isn't it? It feels a little bit like magic. How on earth does something you can't even see, an electric current, create a very real, very powerful force that can spin a blade or turn a wheel? Well, it's not magic, it's physics. And honestly, it's just beautiful.
Okay, so to understand how a motor works, we have to start with just one single fundamental principle. This is the secret that unlocks the whole thing.
And here it is. It's this simple. You take a wire, you run some electricity through it, and you put that wire inside a magnetic field, and that wire will physically move. It gets pushed. An invisible force born from this little dance between electricity and magnetism creates motion. That's it. That is the entire foundation for every electric motor.
So what this push really is just magnetism doing its thing. As this quote explains, what we're really doing is creating electromagnets that are playing a game of tug-of-war. They are constantly trying to line up with each other, North Pole to South Pole. It's that relentless attraction that creates the turning force.
All right, now that we know the basic force that's at play, let's meet the two characters that make it all happen. See, in every electric motor, there's this constant dance, this drama, playing out between two main parts. And this diagram shows the setup perfectly. You've got an outer part that stays still, and an inner part that spins, and they're separated by this tiny little air gap. It's right there, across that gap, that all the magnetic forces do their work and make the magic happen.
So let's properly introduce our two key players. First, you've got the stator. Easy to remember. It's stationary. It stays put, and its job is to create the magnetic field. Think of it as the racetrack. Then you have the rotor, and just like its name sounds, its job is to rotate. It's the race car, always reacting to the stator's magnetic field.
Probably the best way to picture this is to think of it as a magnetic chase. The stator creates this magnetic field, and the rotor, like a little compass needle, desperately wants to line up with it. But, and here's the trick, just as it's about to catch up, we instantly change the field, forcing the rotor to keep on chasing. It's this never-ending chase that creates powerful, continuous rotation.
Okay, so we've got the theory down. A stator and a rotor locked in a magnetic chase. But what does that actually look like inside a real machine? Now, there are tons of different types of motors, but to really see the core ideas in action, we're going to crack open a classic DC, or direct current machine. It is the perfect blueprint.
This schematic is perfect. It's like we're looking at the actual architectural plans for a motor. You can see all the key parts laid out, from the outside shell right down to the spinning core. So let's break down what each of these bits and pieces actually does.
Now, what's really cool here is how this all gets organized. You can see how every part fits into one of two teams, Team Stator or Team Rotor. The yoke and the field windings, they're on the stator's team. They're stationary, creating that magnetic playground. And the armature and the commutator, they're on Team Rotor, the part that's actually doing the spinning.
So first up is the yoke. This is basically the body of the motor. It offers physical protection, sure, but its real job is to be a superhighway for the magnetic field. It guides the flow, the magnetic flux, and concentrates all that power exactly where we need it.
And now we get to the heart of the machine, the armature. This is our rotor. This is the component that holds all the coils of wire that carry the electric current. As this thing spins inside the magnetic field, those wires feel that physical push we talked about, and that is what creates the twisting force we call torque.
And right here, this is the most ingenious part of the whole design. The commutator. You can think of it as the motor's secret weapon or its brain. Remember that magnetic chase we talked about? The commutator is the thing that keeps the chase going forever. It's this really clever mechanical switch that flips the direction of the electricity at the perfect instant to
to keep the rotor spinning and spinning.
So here's how its brilliant little trick works. First, electricity flows into a coil, turns it into a magnet, and it gets a push. Then, as it spins halfway around, it makes contact with the commutator, which, bam, instantly reverses the current. This flips the coil's magnetic poles, so instead of stopping, it gets another push on the same direction. It's just this brilliant, continuous cycle of push, flip, push, flip.
Okay, so we've seen how you turn electricity into motion. But what happens if you do the exact opposite? And this brings us to one of the most elegant and beautiful secrets in all of physics.
Just look at this diagram. You can see the energy flowing from the electrical side to the mechanical side. That's our motor. But look at that arrow pointing the other way. What if you just grabbed the motor shaft and started turning it by hand? Or what if you hooked it up to a windmill? What would happen then?
Well, the incredible answer is you'd get a generator. As the source material says so clearly, a motor and a generator are basically the exact same machine. The parts are identical. The only thing that changes is which way the energy is flowing.
It really is just two sides of the same coin. With a motor, you put electricity in and you get motion out. With a generator, you put motion in by spinning the thing and you get electricity out. It's the same device playing two perfectly opposite roles. This duality is, and I'm not exaggerating, fundamental to our entire electric world.
So let's just zoom all the way back out. We started with this one simple little law of physics. A wire with current and a magnetic field gets a push. And from that, we've built a machine that can both create motion and generate power. The impact of that is, well, it's almost impossible to overstate.
I mean, this single invention is a cornerstone of our entire technological world. It's what powers our factories, it runs our homes, it's at the very heart of robotics and automation, and of course, it's driving the clean energy revolution with electric cars. This simple spinning machine has truly, completely remade our planet.
From a simple magnetic chase to a force that spins the world. This elegant principle of converting energy is more important today than it has ever been. So I guess the question to leave you with is this. As we keep pushing into a more electric future, what new revolutions will be kicked into motion by this humble, brilliant machine?